Hello friends, welcome to AI Flux. Today, another exotic competitor to Stable Diffusion XL was released, and this time, it's not from China, it's not from Canada, it's not from the moon, it's actually from Russia. This model is called Kandinsky, and they just released their 2.2 update. Now, this model is quite different from things we've seen before. However, there are strong similarities to some other larger Stable Diffusion models we've seen. And although it maybe isn't as performant as some of its Western counterparts, I think it's pretty cool. And the biggest thing that's really impressive to me is that somehow there's still enough GPUs in Russia, or people are achieving access to US GPUs in enough volume that they've been able to train this and actually iterate multiple times, even in the last few months, given sanctions. So Kandinsky is named after a Russian contemporary artist named Vasily Kandinsky. He was most active in the early 1900s, right around the same time when Henri Matisse, a French artist, was also dealing with contemporary art in new ways. So at a high level, this model can produce 1000 by 1000 pixel images natively. So obviously, Stable Diffusion XL can push these boundaries a bit, and it's a little weird that this model right now has to only produce square images. So the background of this model is actually quite interesting. It's a project that's actually been created by Sberbank, which is a financial technologies company based in Russia. They're basically a bank. And the way this happened is actually pretty similar to how Salesforce, an American or marketing software company, came to actually create one of the best fine-tunes of the Llama LLM. This is actually version 2.2, so they've been iterating on this model quite a bit over the last few months to a year, and here's what they have to say about it. So basically they say, and this is a translation, so it might be a little off, 2023 can be safely called the year of rapid development of generative artificial intelligence. This applies not only to the usual image modality, think Kandinsky 2.1, Stable Diffusion XL, but also text, so LLMs, a number of modalities. At the same time, it's almost impossible to single out an objective leader in any of the areas. All teams are trying to move forward evenly and improve the quality of synthesis. Text chatbots have learned to interact with external systems through plugins, and we've gotten to video. A little more than 3 months have passed since the first release of Kandinsky 2.1, and today we're announcing the next version, 2.2. And if the architectural model has not undergone drastic changes, then in terms of expanding the functionality, it has received significant development. First of all, we focused on improving quality of generations and the resolution, as well as new possibilities for image synthesis. So this is all basically very similar to Stable Diffusion. So there's been a moderate increase in the native output resolution. Okay, so you can have different aspect ratios. I wonder if that's just achieved with cropping. Okay, so photorealism, they implement a control net, and they have a feature just for making stickers. All right, that's a new one. All right, so they've had 70 million generations and 1 million unique users. So as far as Stable Diffusion, some of these other models have gone, that's actually not huge. The biggest difference with a lot of Russian models is they only integrate with Telegram, which I guess makes sense. They're using diffusers, which is pretty common with this stuff. The Russian version of Hugging Face is generally this website called fusionbrain.ai. And I will say, it's interesting to see these implementations work as well as they do, because they have none of Google's infrastructure, they have no Amazon AWS, and the structure of these systems is actually quite different just because of, at this point, their access to hardware that is so different. So this is a rough outline of how they've actually set this model up. So similar to a lot of other models that do this from text to image, they start with clip, they go to a diffusion mapping, and they go to some form of further image embedding or a latent diffusion net. And this is interesting, but nothing stunning. They say here the main change within the basic architecture is the replacement of the visual encoder for training the image prior model with a larger clip VITG. It's the quality of generated images due to the replacement of the encoder. The diffusion mapping model had to be retrained and then fine-tuned. So maybe not quite as general, maybe a little bit of cherry picking involved here. So here they show their image-to-image functionality, as well as kind of a cool fusion function. I'm sure someone has done this with Stable Diffusion, maybe just not, it's something that's publicly available. But this is a flow I actually haven't seen before. So something they call image fusion and fusion with text, which is basically like taking image to image with the text prompt and just replacing an image clip with instead of text. Okay, that's kind of interesting. And now they get down to parameter counts. Okay, so these are based on latent diffusion models. Makes sense. The parameter bump for 2.2 wasn't massive. The text encoder appears to be basically the same, at least in terms of parameter size. The data set is larger, so maybe they have a better hookup for Chinese labor to model things. I'm very surprised they're even able to post this to Hugging Face and GitHub, but they do. And it looks like they're really proud to showcase some control net functionalities. Edge detection is something that's been done before, but it's cool to see this in potentially a novel implementation. So some other interesting things here. They talk about how they got control networking. And then what's also interesting here is apparently they fine-tuned most of this on 8 GPUs. So really the thing that I'm curious about this is, given the amount of compute they actually have access to, how efficient is this relative to Stable Diffusion XL? Because obviously a big benefit of Stable Diffusion XL is it gives you much better capability with less raw compute, which I think is pretty cool. So these are some comparisons from 2.0 to 2.2. Clearly they've gotten much better, but I would say the difference between 2.1 and 2.2 is negligible. There's certain aspects that are maybe better, but it's interesting enough. So then they have some cherry-picked generations here. So these are sort of product-focused or subject-focused, which are kind of cool. I still think landscapes and very detail-oriented prompts show the best capability. Curiously, at least on Discords, it appears that this model is pretty wide open, so different from the notion of AI safety that Stability AI has and more some of these Western counterparts have. So apparently there's like no filter at all, which is kind of interesting. You might not want to put in, like Soviet things that are bad. I'm sure they have some rudimentary stuff there. And this is mostly accessible through a Telegram bot, but I really dislike Telegram because it's kind of an annoying app. And it's at this point it might be Russian spyware. What's cool is this is technically all available on GitHub. Would I clone this to a machine I have? Probably not. We all found the Stable Diffusion XL 0.9 weights. I worry less about those than this, to be honest. So the comparisons to Stable Diffusion 1.5 and Stable Diffusion XL is kind of interesting. One thing that I find curious about this is Kandinsky 2.2 appears to fall victim to this sort of airbrushing effect. So this is Stable Diffusion XL, this is Stable Diffusion 1.5, and this is Kandinsky. Honestly, I would compare Kandinsky more to Stable Diffusion 1.5 with a really good upscaler. It does well with landscapes, but you can tell it's struggling to interpolate detail and relative scale. One thing that Stable Diffusion XL does really well is understanding what is in the foreground and in the background, and then understanding how to fill in a way that doesn't seem too programmatic. One thing that's interesting with Kandinsky is you get artifacts that you would expect to get with a lot of procedural image generation algorithms, which I find interesting. So like a really great example of that is you can tell that your eye wants to think this is maybe like a waterfall, but the model's having a really hard time shaping this differently than it did every other cliff face. You can try this out on Replicate as well as Hugging Face. My recommendation, per usual, and again, you should check them out on YouTube, is to use one of Kamanduru's implementations. Right now, there's a live demo on editor.fusionbrain.ai, which is technically backed by Sberbank. And also, Kamanduru has a collab, and I still think the collabs are the best. So while Google is actually shoveling money into collabs still, I think you should totally try it out there. I want to show you the demo here. It's interesting just because it's very, very different, and I actually have to run Google Translate to English. You have to agree to responsible use, which again, the interpretation of AI safety with tools outside of the US, I always find interesting. And they claim that if you use it weirdly, they'll ban you, but we'll claim to accept that. So let's see, I'll say Cyberpunk Moscow City at night in the rain. Let's see how fast this is. So this interface is pretty good. It reminds me of kind of the more generic like get image interfaces. And okay, so this is not maybe off, we're not off to a good start. Okay, so Cyberpunk Moscow. We'll give it one more. We'll give it one more try. And granted, they might just be. They're probably just blocking anyone who's using this in America. So yeah, if you want to use this, definitely check out Kandinsky's Google Colab. Let me know what you think. I think this model is pretty cool. I don't think it's really as advanced as SDXL. Granted, it's a really valiant effort. As always, if you like this video, please like and subscribe. And we hope you learned something, and we'll see you in the next video.